In this project, a DAC is implemented using SysTick interrupts that generate the digital wave. This wave is then converted to an analog signal. The program has 4 modes that switch between outputting a sine wave, triangle wave, square wave, and piano mode. The PF4 pin, switch 1, is responsible for switching between these modes. When in piano mode, an input from a 4x4 matrix will play one of the 8 defined notes. This is dependent on which button is pressed. We begin by initializing port F so that we can use the onboard switch in LEDs. The LEDs will be used to designate which mode we are in. In the sound file, we instantiate 3 digital waves, set up the output bits for the DAC, and initialize the SysTick. The waves needed to be digitally built are a sine wave, triangle wave, and square wave. Since we are working with 6 bits, we can count up to 64 elements. Therefore, an array size of 128 is required to build our digital waves. A function is instantiated so that we can choose which of these waves we are going to use. Again, this is dependent on the mode we are in when in main. We then initialize port A on pins 2 through 7. Finally, we set up our SysTick and handler. Note: on line 99, when we assign data to port A, it is necessary to shift by 2 as our starting pin is A2. Initializing the keypad is fairly straightforward. We are using ports C and D as inputs and outputs, respectively. We then perform a scan that looks for an intersection where both the row and column are logically 0. A char value is returned based on this position. The main portion of this project puts everything together. We define the period of the notes to play when in piano mode and the variables we need. When we enter the endless while, we read the input from switch 1. This input determines the color and waveform that will ultimately be output the speaker. When piano mode is entered, we revert to using the sine wave, and case statements are used to determine the output to the speaker. We exit when switch 1 is pressed again. The final lines of code are written so that the output to the speaker can remain continuous while in the first 3 modes.